Hello everyone, my name is Marvin Sendi Kadiwa, and for this presentation, we shall be reviewing a paper about credit card fraud detection using state-of-the-art machine learning and deep learning algorithms. So we all know that credit card is a type of identity theft in which someone other than the owner makes an unlawful transaction using a credit card or their account details. So these cases are growing exponentially now that most of businesses are transitioning into online and they support online payments. So the literature review, so the author considered a lot of existing work before they worked on their solution. So that is most of the existing work, they address this problem by using deep learning, machine learning, and other approaches. So for this presentation, we shall be reviewing the supervised machine learning approaches that the author reviewed. So it was noted that for existing work, most researchers use the random forest approach to combat this problem. However, the author for this paper now tries to use random forest as well as network analysis to come up with a novel solution to combat this problem. So that's how this work contributes to the existing literature. So yeah, so we are going to go through all these different techniques that were used or combined to come up with this paper. So then over to the research methodology. So these are the steps that the author went through to when they acquired the data set in order to train their models. So first, the first step was called feature listing. So this involves identifying the key features in your data set that will help you to base on to determine whether the transaction being carried out is a fraud or a non-fraudulent. So for the dataset description, so the dataset it was collected within 2 days, and it had about 284 transactions, of which less than 1% of them were fraud transactions. So, and then the author disclaims that the customer details for these transactions were hidden, but so because this is sensitive information, much as this data is available for research, we need to have that element of anonymity. So the author addressed that by using something called a principal component analysis. So this is whereby you reduce the dimension of the data and you increase the interpretability of the data and reduce the information loss, because at this point the data set does not have things like PANs or expiry dates. They are somehow masked. So these are the characteristics that were identified in the data set. First is the time. So by time here, it's not the transaction date, but rather the difference between the first transaction and the next transaction, because that's how you identify a fraud. So there was that feature in the data set. And then second, there are attributes added to this data by using the PCA principle, whereby the dimensionality of the data was reduced. Then the amount, then the class label. So by the class label, here the data, it means that the data was labeled. That is for all these transactions, there was a clear indication that this is a fraudulent transaction. Onto the research methodology. So the applied machine learning techniques that were used are one, extreme learning method or extreme machine learning. So this is whereby you feed a data set into a model and you let the model to generalize this data. So this method is highly performant and it's extremely good at generalizing data. Then the second one that was used was decision trees. So the decision tree was limited to a maximum depth of about 4, and there was a criterion set, something called an entropy, which is similar to a maximum depth, but except for it can decide when to stop traversing the tree. So that is when the next decisions to be made will be futile. That is, it could be that you have a specific transaction, and before you go to a depth of 4, probably somewhere around at a depth of 2, you already know that this is a fraudulent transaction. So there's no need to execute the bottom of the tree. Machine learning method that was used is the k nearest neighbor. So this is a supervised learning technique whereby it first takes in a set of labeled data, and then it forms classes. So the two classes that were formed in this data were the fraud transactions and the non-fraudulent transactions. So those are the two classes that we need to base on. Then for a given transaction that comes in, we need to identify where it lies the most. Okay, so we check whether it's most of its features are near the fraudulent transaction or the non-fraudulent transaction. So if they are near the fraudulent transactions, then we can easily classify that incoming transaction that's a fraudulent transaction. So another supervised machine learning technique that was used is random forest. So random forests are made up of decision trees. So let's say you have a random forest made out of 3 decision trees. So you will have to subject a given transaction under all these different decision trees. So if the first decision tree concludes that the transaction that's being checked is fraudulent, and the second it concludes that it's non-fraudulent, and the third concludes that it's fraudulent, then you will know that if 2 out of 3 of these decision trees say the transaction is fraudulent, then you can conclude that it's fraudulent. So this is extremely good when it comes to complex data as compared to the decision trees on their own. Another supervised machine learning technique that was used is support vector, and these have their own advantages in that it's easy to visualize them. So they also work in a way that I think of them as something that is plotted on a graph, whereby for all this data that is labeled, you first plot it on a different graph, and then you come up with let's say a line or a curve that best fits the data, and then you will depend on that curve to make the decision. So they are extremely powerful technique as well. Then the other one is logistic regression. So what is logistic regression? So logistic regression, for it works with discrete data, unlike linear regression, whereby the data is continuous. So in logistic regression, it's also something that can be plotted out on a graph, whereby what you want, whereby the output is a Boolean. That is the transaction fraudulent or non-fraudulent? So that is a true or false evaluation. So you plot out these different characteristics on also sort of like a 2D plane, and then come up with a curve that best suits the data, and then with that, from that curve, you can easily conclude whether the transaction is fraudulent or non-fraudulent. Then another mechanism that was used is XGBoost. So XGBoost is also made out of decision trees. It's an extremely complex machine learning algorithm that's powerful in a way. And here the author used the scikit-learn API. So to be more precise, they use the feed function to leverage this machine learning algorithm of XGBoost. So the performance evaluation measures that were taken were, one, the accuracy. So amongst all the different techniques, like we mentioned before, they were compared in terms of accuracy, and it was found out that most of them had over 99% accuracy. So the accuracy was computed by getting the true positives plus the true negatives divided by the true positives plus false positives plus true negatives plus the false negatives. So then second, the precision, it's another metric that was considered when it came to performance of these models. So their precision was calculated, and the formula for that was the true positives divided by the true positives plus the false positives. So the F1 score as well for each of these algorithms, each of these models was computed, and as well as their record, and they are compared in all these different metrics. Then the data visualization. So the output of the training, the testing data was as follows. So the blue line here represents the total number of transactions that were in fraud, whereas this one in orange, it's the fraud case. So yes, as mentioned earlier, the different machine learning techniques, that is the logistic regression, the linear regression, SVA, the K's nearest neighbor, they were all compared, and a confusion matrix was generated to further compare these different techniques in terms of performance. So the amount The amount, it was standardized by using the standard scalar method in Python. So that is to prevent amounts that are way out of range. So it helps you come up with a proper graphical representation when you standardize the amounts. Then for the conclusion and the future work, so yes, credit card fraud detection cases are still increasing. So as much as there are different models there that are available to detect this fraud, there are people still come up with new techniques. So models need to be evolving. So with this model deployed in production or being used in one of the systems, it will combat those new techniques that are being used to carry out fraud as compared to the old models that are not subject to change. So thank you very much.